Hello everyone, I'm Dr. Ashok Pache. Today in this module, I'm going to explain about how to do modal analysis by using a finite element analysis tool. Here I'm using Ansys. So here I'll show you one example of modal analysis of aeroplane wing. And I will explain the step-by-step procedure how to do it by using graphic user interface of the Ansys. So first thing, we will select the type of problem here, and that is a problem is structural problem. And now I will use here an inbuilt 2D model of the airplane wing, which is available in the Ansys folder only. You can just go to file and just say read input from. Where the Ansys is installed, you just go to that file v4145, that is the version of Ansys. Then again go to data and models. So in this you will find the last option, that is wing, and this is the 2D model of the aeroplane wing. So this 2D model I will mesh with the 2D elements, and then I will extrude these 2D elements to get the 3D elements. So let's see, first define the element type, add edit, and here go to the add. In solid you will find the chord, that is a 2D element as well as the brick element. So chord 4 node, I will select first chord 4 node as a 2D elements, and as I said I want to extrude this 2D into 3D. I will select one more element, that is brick element. So these two elements will appear here, then you can use this option. Once you select the element type, the next most important step is the material properties, and you can go to material properties in material models. So structural, linear, elastic, and isotropic. Here you have to use the Young's modulus. So whatever material you have selected, you have to define the modulus of elasticity. For example, for this material is a 38000, Poisson's ratio 0.023. Another important property that you have to give, that is the density. So density is, for example, 8.3 into e raised to minus 5. That's it. So this is this material property data is sufficient. We'll exit from this. Now we have to define mesh it. So for that you go to the meshing, then mesh tool. First you have to define what is the element edge length, and that you can in this mesh tool say global, and you have to set it. So set element edge length, for example it is a 0.25. As per the domain structure you have to select what should be the minimum element size. Number of divisions, for example 10. Once you define this, just go to we are using here the free mesh. So free mesh, and it is asking which area you want to select. So whatever displayed area, I will just say pick all, and it has been meshed now. So once you mesh it, as I said, I want to extrude this into 3D elements. So I will go to modeling and extrude. So in that element extension option is there, where this is the 2D element, and I want to extrude this into 3D. So number of element divisions, for example 10, and just say my all other options are default, keep it as it is. Now just go to the extrude by XYZ offset, because I want to extract this in a Z direction. Pick all elements, and in Z direction dx divide dz. So in Z direction element edge length is 10. Okay, and you can see now in 3D it has been extruded into the 3D. So now once you do this, these 2D elements which initially I use, I don't need these elements anymore. I will just go to the entities, and for example these elements by attributes, I will element type number. Initially I had defined this element, one element as an element type number 1, which was a 2D element. Unselect is apply. Okay. So that 2D elements I have removed because it will not take part in the simulation. Only 3D elements will be there. Now once this meshing is done, okay, and now I have to define the boundary conditions, which is most important. So what I will do, go to the loads, define loads, apply, structural, displacement, and node point. So this, nodes. Okay. Now I will select this node by box. So once you select this, just click on this box, just say OK, box, and apply. Nodes and these structural nodes, and I will say box. This box appears, select. All nodes have been selected. Let's say OK. So all degrees of freedom in this will be a 0. So it has been constrained in one direction. Once you define the nodes, because it is a modal analysis, so it is under free vibration, so in the absence of external forces, so I have given the under loads only the displacement is constrained. Now in the solution we have to define the analysis type. New analysis, so obviously this is the modal analysis. Analysis options further, we are using here block Lang's algorithm. Number of modes to extract is 5, number of modes to export is 5, for example. Okay. Once it is done, just save it and we can solve it. Current solution. If you are getting this solution is done message, then everything is correct. We can see the results. For that purpose, just go to general post processor and see the result summary. So here you got the table where first, second, third, fourth, and fifth natural frequencies are there. You can close this and you can just see animated results in ED results. So first set, just to go to the plot controls, animate, mode shapes, deform, undeform, okay, and you can see now here, just see in the another view, and so you can see this first mode shape. So this is the first mode shape. We can stop this, close this, go to the next set, again repeat the procedure, plot controls, animate, mode shapes. So this is the second mode shape. Okay, this is the second mode shape. Close. We can see the third mode shape. And this is the third mode shape. This is third mode shape. Stop, close, go to the next. We'll see the fourth mode shape. And this is the fourth mode shape. This is the fourth mode shape. Stop, close, and we can see the final one, that is the fifth mode shape. So this is the fifth mode shape. So in this way we can find out the natural frequencies and mode shapes of any particular structures by using finite element analysis tool here Ansys. Corresponding this you can see is frequency and maximum reflection. Thank you.